Okay, we'll do the pig enterocyte first. And so we'll draw a fat droplet right here. That's horrible. Do it again. Okay, I was nervous. That'll be better this time. So this will be the non-ruminant. Lipid. Okay, and what we primarily have in the non-ruminant lipid fat droplet is tag, 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 more tag, and then a little bit of DAG plus free fatty acid. Okay, and that's basically, the green represents the bile, which has stabilized this small little fat droplet, and we're going to have two proteins attached to it. We're going to have co-lipase, so Cl, and then pancreatic lipase. So co-lipase makes a space, says, hey, here's some space for you, pancreatic lipase. Pancreatic lipase grabs a hold, and basically what's going to happen is it's going to break everything down into MAG plus 2 fatty acids. Okay. And then we have two different types of fatty acid. We have like short to medium chain fatty acids, and those are fatty acids with less than or equal to 10 carbons. And they're going to basically go directly through the enterocyte to the blood, where they bind to albumin, and then they go to the liver. Okay, if only everything was short chain fatty acids, we could be done. But we have to do the long chain fatty acids. So the longer chain fatty acids greater than 10 carbons. Okay, they're going to get combined with MAG via the activity of acyl-CoA synthetase. And that's going to make TAG. So we take two fatty acids plus a MAG plus some acyl-CoA synthetase, which is an enzyme, you can tell by its name, and that's going to make TAG. The TAG is going to accumulate in the, find the marker, endoplasmic reticulum. So we have all this TAG piling up in here. It's going to receive a protein. That protein's B48. And that's basically its name tag. And then this is going to move to the Golgi apparatus. Still full of TAG, still has the protein on it, B48. But here we're going to attach some carbohydrate to further stabilize that droplet. And now it is a chylomicron. Which goes to the lymphatic, which goes to the blood, which goes to the muscle, plus adipose. And what we're going to lose is DAG plus the fatty acid. The enzyme that catalyzes that reaction is lipoprotein lipase. And then we have a chylomicron remnant. Which is endocytosed by the liver. Okay. We're going to do the ruminant enterocyte on the same piece of paper. Okay, and we have a fat droplet here, again with bile surrounding it. This one's going to be a little different because it contains a lot of microbial phospholipid. I was going to try and write that upside down, but I'm not that talented. And so it can actually orient itself in a way to minimize its interaction with water, because as we learned a long time ago, phospholipids have a portion of them that is hydrophilic and a portion of them that is hydrophobic. And so the hydrophilic would orient itself out towards the water, and the hydrophobic would orient itself inward. On the inside, we're primarily going to have saturated fatty acids. And the reason these are primarily saturated fatty acids is because the ruminal microbes saturated them. Okay, very few tags or DAGs or MAGs, because hydrolysis in the rumen is rapid and complete. Okay, and saturation in contrast is slow and incomplete. So we'll put a UFA in here just to represent, we'll put 2. Just to represent that they're not all saturated, but the vast majority of them are saturated. The other thing we're going to add is these squiggly lines, and squiggly equals lysolecithin. From an importance standpoint, the enzyme that's going to be most important in the small intestine would be the phospholipase from the pancreas, so pancreatic phospholipase, because that's going to break down the microbial phospholipids. Again, as these products are absorbed, fatty acids with less than or equal to 10 carbons go directly through the enterocyte, where in the blood they bind albumin, and then they go to the liver, and then we're cool with them. Okay? We're going to absorb fatty acids with greater than 10 carbons here in the enterocyte. And we have a challenge, and that's we don't have an adequate supply of MAG like we did over here. Over here in the pig, we have this MAG to synthesize our tag. But in the cow, we don't have that supply, because mainly what we're absorbing would be saturated fatty acids. So fatty acids greater than 10 carbons. We need a glycerol, and so in the cow, that glycerol is going to come from glucose. So we take some glucose, and we make glycerol, and then we combine that, so 3 fatty acids plus glycerol to produce a tag. The enzyme that catalyzes this reaction is acyl-CoA synthetase. Okay, and then this tag goes to the ER, the endoplasmic reticulum. I'm just going to write ER because I'm lazy. And we have tag accumulating in here. Okay, and this tag would primarily be saturated fatty acids. That would be a big difference between these two, is saturated fatty acids, a mixture of saturated fatty acids and unsaturated fatty acids. Okay, we attach the protein, V48, and then this jobby goes to the GA, the Golgi apparatus. So make a triangle. Another fat droplet. I didn't make it very big, so that should be full of tag. Stick the protein on it. Put carbohydrate on it. We should be getting good at this by now. And then we end up with a chylomicron, which goes to the lymphatic, goes to the blood, which goes to the muscle, almost off the screen, plus adipose, which is where we have lipo, protein, lipase. And remember, lipoprotein lipase is going to identify that protein we stuck on and say, hey, I can act on you. And you can kind of think of that protein B48 as like co-lipase for lipoprotein lipase. It creates a room for it or a spot. And then we're going to produce DAG plus fatty acids, which get absorbed by the muscle and adipose. And if that happens enough, we end up with a chylomicron remnant, which goes to the liver and is metabolized away. I want to see something real quick. So pause. Okay, what I wanted to look at was writing assignment number 5. And so you're supposed to answer, what role do proteins play in the digestion, absorption, transport of lipids? Please do not make this harder than it needs to be. So think about where proteins are involved in their digestion and basically write about it. It's not supposed to be hard. And then kind of create a list of what proteins are involved in the aforementioned processes. So think enzymes and transporters. So that would be in the non-ruminant animal. Question 3, answer what differences exist between non-ruminant and ruminant chylomicrons. Okay. So we have a chylomicron here and a chylomicron here. Okay, and basically what I want you to do is work backwards and think about how these chylomicrons differ. Okay, what's the big differences that exist? So they're both tag, so that would be a similarity. They both have B48 and carbohydrate. So what you're really looking at is how the fatty acids differ. Where does the glycerol come from? Those are the things I want you to talk about. And then why do these differences exist? And how does it change the way you would feed each species? So if you wanted to provide a specific fatty acid, what would you have to do to get it in the pig versus what you'd have to do to get it in the cow? I really want you to think about that for the test. So, good? I will stop this. If you guys think the videos are helpful and you're listening to this, so I didn't stop it, I would appreciate you letting me know that the videos are helpful, because sometimes it feels like maybe 5 people look at it. But if it's really meaningful and useful, that would be a good thing to know. And I hope you enjoyed watching them. Enjoy, it's probably the wrong word. I hope it was useful.